Welcome everyone! Today we're going to explore the world of human-machine interfaces, or HMIs, focusing on a crucial aspect, serial communication. This is the language that allows HMIs to interact seamlessly with devices like Programmable Logic Controllers. Understanding HMI serial communication is key to leveraging the full potential of these interfaces. It's what enables us to monitor and control complex systems, from industrial machinery to home automation systems. So join us as we delve into this fascinating topic. Serial communication in human-machine interface systems is a fundamental aspect that allows HMI to interact with other devices like programmable logic controllers and sensors. Serial communication is a process where data is sent sequentially over a communication channel. It's a widely used method for short-distance communication between devices. In the context of HMI, serial communication enables the HMI to send commands to and receive data from connected devices. There are multiple common serial protocols in HMI, such as RS-232. This is a standard for serial communication transmission of data. It's commonly used for connecting a computer to a modem or a printer. The RS-232 standard allows for simple, direct communication between two devices. However, it's limited by distance and speed. It's typically used for short-distance, low-speed requirements, such as in a lab setting or for connecting peripheral devices. RS-4852. This protocol allows for longer cable lengths and the possibility of having multiple units on the same bus. This makes it ideal for industrial environments where devices may be spread out over a larger area. RS-485 supports multi-point systems, which means you can have multiple devices communicating on the same network. This is particularly useful in complex systems where you need to control and monitor multiple devices. RS-422 or RS-4854 has a longer reach and higher data rates. It's also a differential signaling standard, which means it sends two voltage levels for each bit. This makes it more resistant to electrical noise, allowing for reliable data transmission over longer distances. It's often used in environments with high levels of electromagnetic interference. Beyond RS-232, RS-4852, and RS-4222, RS-4854, there are other standards like USB, Ethernet, and Fieldbus that might be used in more complex HMI systems. Understanding how to program the HMI and connected devices for serial communication is key, enabling effective communication between an HMI and other devices. You can better design and troubleshoot your HMI systems. Also, learning how to use debugging tools to troubleshoot communication issues can save a lot of time. Depending on the industry, there may be specific protocols that are commonly used. For example, Modbus is widely used in industrial applications for serial communication. To establish serial communication, you need to configure several parameters correctly. 1. Baud rate, the speed of communication, defined in bits per second. Think of this as the speed of conversation. Just like people need to speak at a pace that's understandable, devices need to talk at a certain speed to communicate effectively. This is measured in bits per second. 2. Data bits, the number of data bits in each character. This is the amount of information sent with each word or signal. In human terms, it's like deciding whether to use short words or long sentences. 3. Stop bits, the number of stop bits to signal the end of a character. These signal the end of a sentence. It's a way for the receiving device to know that one piece of information has ended before another begins. 4. Parity, an error-checking mechanism. This is a form of error checking. It's like proofreading a message to ensure it makes sense before sending it. When you're setting up these parameters in an HMI, you're telling it how to talk to other devices. It's like teaching someone a new language so they can have a conversation with someone from a different country. In any communication system, errors can occur. For serial communication, error handling is crucial to ensure data integrity. Techniques like parity checks, checksums, and cyclic redundancy checks, CRC, are used to detect errors in the transmitted data. Flow control is used to manage the pace of data transmission between two devices to prevent the receiver from being overwhelmed by data. Proper grounding is essential in serial communication to avoid potential differences that can cause communication errors. HMIs often use serial communication to interface with other hardware. The communication can be set up using various methods, including direct connection, connecting the HMI directly to another device via serial ports; networked connection, using a network protocol like Modbus over a serial link;